Now you can see this one looks quite complicated, and it may be quite complicated, but the question says for the op-amp based circuit diagram shown, find the value of Ix, IO1 and IO2 as marked. Ix, where is Ix is here, IO1, IO1 the output currents. Please note that some nodes are labeled. We are going to stick to those labels. In case you use them, please use the labels provided. For a parameter not marked, you can use your own labels. However, you must mark whatever current or voltage you use appropriately on the circuit given below. So we just start doing what we best know to do, and that is to write down what we know for sure. So 0 volt, this is 0 volts, this is 0 volts. Because no current is going to flow in here, this must be at 0 volts. So VC is at 0 volts. Similarly, this is at 0 volts. This would be 0 volts, 0 volts, and based on the same reasoning, VD would be at 0 volt as well. So what else we can find for sure is that Vn is grounded. So this is at 0 volt. This is 0, this is 0, but a current is flowing in here. It's okay, is a current source. This is 0 volt, this is 0 volt, but a current is going to flow here because we have a voltage source with a resistor. So you see is 0 volt, this must be a 2 volt, higher voltage, higher potential, lower potential, a current of 2 minus 0 over 2, which is 1 ampere, is going to flow here. In a practical op-amp circuits, such small resistances are never used. But this is a theoretical question looking at knowing whether you can solve op-amp circuits or not. So basically, let us forego with this anomaly for now. Okay, a very high currents are basically flowing in this circuit. This is usually not what is practiced. So we have 1 ampere coming here, 1 ampere coming here. So some would go here, some would go here, we don't know, but let us come up with something that we know for sure. So this is VA and VB are directly connected. So this node and this node is the same. Despite the fact that both of the nodes are same, there is some current flowing in this branch. Does not mean if this voltage equal, you say Ix is 0. That would be absolutely wrong. The voltage, the voltage here is 0. The voltage here is 0 too. So there is 0, 0, 0, but there is still 1 ampere current flowing in here. So basically, whenever you come across such a situation, you find the currents. These currents are going to tell you what this current would be. These currents are going to tell you what this current would be. So let us now, if we have used every for sure thing, then we can resort to writing NVA equations. NVA equations are our best bet here. Let us just have a check. What else we can do? 0 current here. Oh, so this is 0 volts here, 0 volts here. So no current flowing here. This current is 0. Similarly, this current is 0. So if there is no current going here, no current going here, and 1 ampere going here, where is this 1 ampere coming from? It's obviously coming from here. This 1 ampere is coming from here. 0 volts, this must be higher potential. 1 into 1 is 1 volt, so 1 volt across this is at 1 volts. Similarly, 1 ampere coming here, this must be 1 ampere going in here. 1 into 1, we have 1 volt across this in this polarity, and therefore VB is at 1 volt as well. 1 volt, 1 volt, and they had to be at the same potential. Why? Because they are the same node. Okay, so let us see what else we can figure out. We have okay, so just let us write the NVA equations for now. Let us write the NV equation for this node. Despite being at ground, but we have four branches coming, joining here, and with the other nodes at known or labeled voltages, we can write NV equation for the ground node. 0 minus V1 over 3 minus 1, we know the current here, so I'm just resorting to whatever we know. 0 minus V2 over 5, we know the current coming in here is minus 1, so we get this equal to 0. So we have actually an equation minus V1 over 3 minus V2 over 5 minus 2 equal to 0. One equation, two unknowns, so we need another equation. So let us write the equation for this node, and we know the voltage is 1 volt. So how many branches are there? So this is one node. There are four branches, 1 2 3 4. 1 minus V1, 1 minus V1 over 5 plus 1 minus, we know this current is 1 ampere, we can write that 1 ampere straight away, or 1 minus 0 over 1, which is the 1, and then we go here because the same node, and we can write plus 1, this current going outward, and then this current 1 minus V2 over 1 equal to 0. So what do we get here? 1 over 5 minus V1 over 5 plus 1 plus 1 plus 1 minus V2 equal to 0. Once again, two equations, two unknowns, minus V1 over 5 minus V2, 1 plus 1 plus 1, 3 plus 0.2 plus 3.2 equal to 0. Second equation. Solving these two, we can obviously find the value of V1 and V2. So let us solve this and find V2. V2 is 3.2 minus 0.2 V1 from equation 2, and from equation 1 then we have minus V1 over 3 minus 3.2 minus 0.2 V1 over 5 minus 2 equal to 0. So we get V1 common with minus 1 by 3 with plus 0.2 over 5 with minus 3.2 over 5 minus 2 equal to 0. So we have V1 equal to 3.2 over 5 plus 2 divided by 0.2 over 5 minus 1 by 3. I don't have a calculator, but we assume we are going to find a value for V1 here. So finding V1, we can easily find V2 from this expression. So once V1 and V2 are known, we can very easily find these currents. Let me label them I2 and I1. I hope there are no I2 and I1 in the circuit. So once I2 and I1 are known, how would we find I1? I1 is equal to V1 minus 1 over 5. V1 minus 1 over 5. What would be I2? I2 would be equal to V2 minus 1 over 1. So we get value of V1 by solving, value of V2 by solving, I1 and I2. And then we can find the value of IO1 and IO2 to be, so IO1 is the inward current. So let me apply KCL here now. So minus IO1 plus I1 plus V1 minus 0 over 3 equal to 0. is going to give us the value of IO1 equal to I1 plus V1 over 3, and similarly minus IO2, the inward current, plus the outward current, plus the outward current V2 minus 0 over 5 equal to 0 is going to give us IO2 equal to I2 plus V2 over 5, and we can find this. In the comments, write the values of V1, V2, I1, I2, and IO1 and IO2. V1, V2, I1, I2, IO1, and IO2. I will soon update this. Afterward, I am going to solve this and write down these values and share it.